All right, our next step or parts for our Unit 5.1 notes is our exponent properties. For these that we're going to review, a lot of this you should have covered in Algebra 1 and talked about before, but that was a while ago, so we are going to refresh our memory. So product, if you have the same base and you are multiplying them together, you are going to add the exponents. So an example, if you had x to the power 3 times x to the power 2, you keep that base and then you take 3 plus 2, and that will give you the new exponent of 5. And the reason that works is x times x is x cubed, and then we're multiplying it by x squared, which is just times x times x. So all together, we have 5 x's that are being multiplied. So we have x to the power 5. Next, our quotient rule. If we are dividing, we are going to be subtracting. And I'm going to show you 2 different examples for this one. So if we had x to the power of 4 over x to the power of 2, that would simplify to just x squared. The reason that works is because the top, we have 4 x's being multiplied together, divided by x times x. So these just simplify with each other. So we just took this and we subtract it from the top, and that gave us x squared. Another example is, what if we had it the other way? If we had x squared over x to the 4, that is going to be 1 over x squared. So the reason that it works this way for this one is because we only have 2 x's on top and 4 on the bottom. So when we cancel those out, we still need a placeholder for our fraction. So we are going to put a 1 up there, and then we have the 2 x's that are being multiplied together on the bottom. And that's where we get 1 over x squared. So we took those 2 from the top and subtracted them from the 1 on the bottom. Okay. Then next we have a power of a power rule. So that's when you have some base with an exponent raised to another power. Those are just going to be multiplied together. So an example, if we had x squared raised to the power of 3, that would just be x to the power of 6. And the reason that works is because we have x squared raised to the power of 3. So that means we have x squared times x squared 3 times. And we just talked about how this means we would add the exponents. So 2 plus 2 plus 2 is 6. So instead of having to write them all out, we can take the shortcut of just 2 times 3, because we would have the 2 exponent 3 times. Okay. Our next one, we have a product of or power of a product rule. So if we have an exponent, it is applied to both parts. So whether it's 2 variables or a coefficient in a variable, the exponent on the outside has to be applied to everything in the parentheses. And what that would look like is if we had a problem, let's do 2x raised to the power of 2. This means we have 2x times 2x, 2 times. And hopefully from your algebra, you would know you would multiply the 2 coefficients together, and 2 times 2 is 4, and then you'd multiply the exponent, or the variables together, x times x, which is x squared. And you'll notice that's the same thing as having 2 squared x squared. It is just the simplified answer, because anytime we get a number with an exponent, we want to make sure we simplify. So your final answer would just be 4x squared, and that is where that comes from. Okay, next we have a power of a quotient rule. So we have a over b raised to the power of m. For this one, anytime you have a fraction, that exponent gets applied to both the numerator and the denominator. So for example, if we had 2/3, we'll have it squared. We would have 2 squared over 3 squared. That gives us 2 times 2 is 4, and 3 times 3 is 9. The reason that works is because 2 over 3 squared means we have 2 over 3 times 2 over 3. And if you multiply your fractions just straight across like you should, you would get the same answer as 4 over 9. So that's why you have to apply it to both the numerator and the denominator. Okay. Our next one, our zero exponent rule, means anything raised to the power of 0 equals 1. And for this, we're going to list out a few things. So we know that 2 to the power of 1 equals 2. And then 2 to the power of 2 equals 4. And 2 to the power of 3 should equal 8. So as we go backwards, we are dividing by 2 as we take away 1 from the exponent. So we went from 3 to 2 to 1. So if we keep that pattern going to get, 2 to the power of 0, 2 divided by 2 is going to give us the number 1. And this works for all numbers, not just 2. So if I replace this with a 3 or a 4 with the exponents, the same pattern happens because every time we increase the exponent, we're multiplying it by itself one more time. And every time we decrease it, we're dividing it by itself that number of times as well. So that's where the 1 comes from. Anything to the power of 0 will always equal 1. Okay, that leaves us to our last one, our negative exponent rule. For this one, if we have a to the negative m, that is equal to 1 over am. And for this, I'm going to reference our quotient rule. So for example, when we had x squared over x to the 4, we knew that that simplified to 1 over x squared. So let's check, what if we were to just subtract those exponents? If I did 2 minus 4, that would give us x to the negative 2. And that is true. These are all equal to each other. So whenever you have that negative exponent, it just means if it's in the numerator, you're going to move it down to the denominator to make it positive. The same thing is true for if the negative is on the bottom or in the denominator. So if we had 1 over x squared, or negative 1 over x to the negative 2, we would want to rewrite that with a positive exponent. So because it's in the denominator, we need to move it to the top, so then it becomes a positive x squared. And then on the bottom, you would just have a 1 or whatever was still remaining in the denominator. Okay, that is just a quick explanation of all the exponent rules. I went really into depth, so if you're watching this, it's probably because you were not in class. I wanted to make sure that I was very thorough in case you had questions. If you still have questions, make sure you let me know. If not, hopefully this addressed everything that you were confused about with your exponent properties. The next video, we'll go over the examples from the notes.